Air defense systems are built around a simple promise: if something flies towards you, it will not arrive. For a while, that promise holds. Radars track, launchers fire, interceptors collide mid-air. From the outside, it looks like technological control, a shield made of software, steel, and precision engineering. But air defense has a structural weakness most people never see. Every successful interception consumes the very thing that makes protection possible: missiles. And missiles are not software updates, they are industrial products. They require factories, supply chains, specialized components, time. So here is the uncomfortable question modern warfare keeps asking. What happens when a modern air defense system runs out of missiles? Does the shield slowly weaken? Does it partially degrade? Or does it simply vanish all at once? Tonight, we are not asking whether air defense works, we are asking something more structural. In a war measured in months, not days, which matters more, the sophistication of the interceptor or the ability to keep firing on day 100? Because in modern conflict, the shield does not fail when it misses, it fails when it cannot shoot at all. Modern air defense is often evaluated by performance metrics: range, radar sophistication, interception rate. Systems such as the Patriot, the S-400, or Iron Dome are typically discussed in terms of how far they can see and how reliably they can hit. Those metrics measure tactical performance. They do not measure endurance. Because air defense is not only a sensor and shooter problem, it is an inventory problem. Every interceptor fired reduces the defender's remaining protection. And unlike aircraft, ships, or armored vehicles, interceptors are single-use assets. Once launched, they cannot be recovered, they cannot be repaired, they cannot be reused. This creates a structural contradiction. The better an air defense system performs under heavy attack, the faster it consumes its own future capacity. In short conflicts, this may not matter. Stockpiles are designed around expected campaign durations. Production lines are calibrated to peacetime demand. But when conflict stretches beyond assumptions, when missile and drone attacks become daily rather than episodic, air defense stops being about technology. It becomes about throughput. An advanced interceptor used in systems like Patriot can cost several $1,000,000 per missile. Meanwhile, many drones and loitering munitions cost a fraction of that. This creates a cost-exchange dilemma. If a defender spends $3 million to destroy a target that costs $30,000, the engagement may be tactically successful, but strategically inefficient. Under limited attacks, this imbalance is manageable. Under sustained saturation, it becomes destabilizing, because the attacker can impose economic exhaustion before achieving physical destruction. The defender then needs to decide: do you intercept every threat, or do you conserve for something worse? The moment conservation enters the equation, coverage becomes selective. Before recent expansion efforts, public reporting from CSIS and Reuters indicated U.S. Patriot interceptor production was measured in the low hundreds per year. Hundreds, not thousands. At the same time, sustained missile and drone campaigns can consume interceptors at a far faster rate. Missiles are not artillery shells. They require precision guidance units, advanced seekers, solid rocket motors, specialized microelectronics. Expanding production is not a matter of writing a larger check. It requires new facilities, new supply chains, trained labor, and long lead components. Defense industrial studies consistently show that surge expansion can take 2 to 5 years. So here is the stress question. If you consume interceptors faster than you produce them for 6 consecutive months, what replenishes the gap? Factories do not move at battlefield speed. This is where modern air defense reveals its industrial ceiling. During prolonged conflicts, open-source reporting has repeatedly referenced concerns over interceptor depletion rates. When governments begin publicly discussing resupply timelines, that alone is strategic information, because deterrence depends on perceived depth. Air defense does not need to hit zero to lose credibility, it only needs to appear finite. Once adversaries suspect inventory is thinning, they adjust tempo. Saturation increases, testing becomes probing. The psychological burden shifts from attacker to defender. The shield becomes conditional. SIPRI arms transfer data shows that advanced interceptor systems are exported in limited quantities relative to demand. Many states rely on a small number of producers. In alliance structures, this creates concentration risk. If one country's stockpile declines, it may depend on transfers from partners, but those partners are drawing from their own finite inventories. For planners calculating long-duration defense commitments, the real question is no longer, can this battery intercept? It becomes, can the combined industrial base outproduce the rate of incoming fire across the alliance? If not, sustainability becomes collective vulnerability. Air defense under stress exposes industrial hierarchy, not technological hierarchy. If recent conflicts have revealed anything, it is this: modern air defense is not constrained by radar sophistication. It is constrained by reload velocity. An interceptor for the Patriot system can cost between $3 and $4 million per shot. Pre-expansion production rates were measured in the low hundreds annually. That means a few intense weeks of saturation can consume a meaningful percentage of annual output. Not total inventory, annual output. That distinction matters because sustainability in prolonged war depends less on how many missiles exist today and more on how many can be produced tomorrow. The same pattern applies across systems. Even lower-cost interceptors, such as those used in layered defenses like Iron Dome, remain industrial products tied to supply chains and component availability. The lesson is not that high-end air defense is flawed, it is that it was optimized for a different stress model, designed to defeat high-value aircraft in limited missile salvos, not daily waves of attritable drones over months. In long wars, the most modern air defense is not the one with the longest engagement envelope. It is the one with the deepest stockpile, the fastest replenishment cycle, the most adaptable cost layering, and the industrial base capable of expanding under pressure. Prestige systems deter at the beginning. Production depth sustains deterrence over time. If interceptor consumption exceeds industrial replenishment for a year, the system does not collapse overnight. It gradually becomes selective, and selectivity is the beginning of strategic vulnerability. Air defense does not fail the day the last interceptor is fired. It begins to fail when commanders calculate burn rate against production rate, when annual output is measured in hundreds and weekly consumption under saturation is measured in dozens. Math replaces confidence. At that point, every launch carries a shadow cost, not just the price of the missile, but the time required to replace it. If expanding production takes 2 to 5 years, every interceptor fired today is borrowing from future security. This is the hidden transition. Air defense shifts from technical dominance to industrial accounting, from can we intercept this to can we afford to intercept this? And once that question enters operational planning, deterrence is already thinning. Because adversaries do not need to destroy the shield, they only need to prove it is finite. When a defender begins conserving interceptors to protect only capital cities or critical nodes, coverage contracts, peripheral zones accept risk, operational flexibility narrows. The system still functions, but it no longer controls tempo. In prolonged warfare, tempo is power. The side that dictates tempo forces the other to consume faster than it produces. That is how modern air defense runs out, not through sudden collapse, but through accumulated imbalance. And imbalance, sustained long enough, becomes strategic exposure. Modern air defense is often described in terms of interception rates. But interception rates are momentary statistics. What decides endurance is replacement rate. If a system consumes faster than it regenerates, it is not a shield, it is a timer. For planners preparing for campaigns measured in months, not days, the question is no longer how advanced a missile is. The question is whether the industrial base behind it can survive prolonged strain. Because in a long war, technology buys time, industry decides duration. And when air defense runs out of missiles, the sky does not change, the balance of initiative does. The side that still produces dictates tempo, the side that conserves reacts. So the real measure of modern air defense is not how well it performs in the first wave, it is whether it still fires in the 50th. And that is not a radar problem, it is a production problem. Military reality under stress.